Hello students, welcome. On our previous lessons on Form 2, we have dealt with the chemistry of structure and bonding. So today we are going to proceed to topic 4, and the name of the topic is called chemistry of salts. We are going to start with lesson 1, and here we are having the definition of a salt. And we are saying a salt is a substance, or a salt is any substance that's formed when the hydrogen atom or when the hydrogen ion in the acid are wholly or partially replaced by a positive ion. And so that positive ion can be a metal, because remember we said metals are positively charged cations, or ammonium ion. An ammonium ion is written NH4 plus. It is a positively charged radical. So here we are saying when the hydrogen ion or atom in the acid, that means all acid they're having hydrogen atom. For example, we know an acid called hydrochloric acid. It is written HCl. When it associates, it produces hydrogen ion and also chloride ion. Okay, if we talk about maybe nitric 5 acid, there's another acid. It's written HNO3. When it dissociates, we get hydrogen ion and also nitrate radical. Then lastly, if we are talking about maybe sulfuric 6 acid, it dissociates to produce 2 of hydrogen ion and also sulfate radical. So here, that's why we are saying when the hydrogen atom or when the hydrogen ion in the acid are wholly or partially replaced by a positive ion. So that positive ion can be a metal or it can be ammonium ion. So next we are saying examples of salts include, some example of salts include sodium chloride, it's written NaCl. We're having potassium hydrogen sulfate, we're having chloride carbonate, and we're having ammonium nitrate. These are some examples of salts. So next we are saying note. Ammonia, which is written NH3, is an unusual base as it does not contain a metal. Remember, when we're talking about bases, we said oxides and hydroxides are bases. So that means we have also ammonia, which is an unusual base as it does not contain a metal. It forms ammonium salts containing the ammonium ion, which is written NH4 plus. That is the positively charged radical. Example. When we're having ammonia solution or aqueous ammonia or ammonium hydroxide and it dissolves in nitric 5 acid, what we are going to get will be ammonium nitrate solution. So this ammonium nitrate is a salt. Next, let's proceed and see the different types of salts. We are saying there are 4 types of salts, namely, number 1, we have normal salts. Number 2, we have acidic salts. Number 3, we are having basic salts. Then lastly, number 4, we are having double salts. So each of this type of salts will be explained in details. So let's start number 1, that is normal salts. What's a normal salt? We are saying a normal salt is a salt that does not contain a replaceable hydrogen atom. We are saying some examples of normal salts include sodium chloride. The way it is written, it is NaCl. That means we don't see any hydrogen atom. Then next, we are having zinc sulfate. It's written ZnSO4. And there again, we don't see any hydrogen atom. Then we're having next calcium carbonate, written CaCO3, and we're having here lead 2 nitrate. So that means these are some examples of normal salts. So we're saying normal salts are neutral in aqueous solution. What does that mean? If we take this sodium chloride and we dissolve in water, what we are going to get will be neutral solution. That means sodium chloride solution will be having a pH of 7. So next, let's proceed to number 2, the second type of salt. We are saying we're having acidic salts. What are acidic salts? We are saying acidic salts are salts that contain a replaceable hydrogen atom. Okay, next, we are saying some examples of acidic salts include potassium hydrogen sulfate. It's written KHSO4. comma, we're having sodium hydrogen carbonate. It's written NaHCO3, and we're having sodium dihydrogen phosphate. So next we are saying acidic salts have acidic properties, and this is due to the presence of replaceable hydrogen atom. What we are saying is that when we take these acidic salts and we dissolve in water, they are going to have acidic properties. Number 3, we are having basic salts. What are basic salts? We are saying these are salts that contain hydroxyl ion. Hydroxyl ion is written OH negative. So let's see some examples of basic salts. We are saying some examples of basic salts include basic magnesium chloride. It's written Mg in bracket OHCl, comma, basic zinc chloride. It's written Zn in bracket OHCl, and we're having basic copper 2 carbonate. It's written copper 2 carbonate dot Cu in bracket OH close bracket 2. That's how we write basic copper 2 carbonate. The next we are saying basic salts have basic properties, and this is due to the presence of hydroxyl ions. So what we are saying is that when we take this basic magnesium chloride or basic zinc chloride or basic copper 2 carbonate and we dissolve in water, it is going to have basic properties. What does basic properties means? It is going to have a pH more than 7. It will be turning red litmus paper blue. That's what we're talking about. The next we're having double salts. That's number 4. So what are double salts? We are saying these are salts that contain 2 different cations or anions. So let's go and see some examples of double salts include Tarona. Tarona, it is sodium carbonate dot sodium hydrogen carbonate dot 2 moles of water of crystallization. Number 2, we're having hydrated ammonium iron 2 sulfate. It is written like this. And lastly, we're having hydrated potassium aluminum sulfate, which its formula is written here. Next, let's go and proceed to solubility of salts and bases in water. So we have rules of solubility of salts and bases in water, and the first rule is that we're saying all nitrates are soluble. What do we mean by that? So if a salt has the name nitrate, it is obviously soluble in water. For example, what are examples of nitrates? We can talk about metal nitrates. Like we take any metal, then we add the word nitrate, and we can take ammonium and we put nitrate there. So it includes sodium nitrate, potassium nitrate, magnesium nitrate, calcium nitrate, aluminum nitrate, zinc nitrate, lead 2 nitrate, copper 2 nitrate, silver nitrate, mercury nitrate. There are very many. Iron 2 nitrate. So we're saying all nitrates are soluble. Number 2, we're saying all chlorides are soluble. Example of chloride include, you take any metal, then you add chloride. What you're going to get is salts of chloride. So we're saying all chlorides are soluble except 2. One is lead 2 chloride. Its formula is PbCl2, and the other one is silver chloride. It's written HCl. Then we're saying not. Lead 2 chloride is soluble in warm water. Like for example, what we have said is that all chlorides are soluble except lead 2 chloride and silver chloride. Again, to differentiate these two, that means the lead 2 chloride from silver chloride, we are going to just heat or warm the mixture. Then we will see lead 2 chloride dissolved in water, in that warm water, while silver chloride will not be dissolving on warm water. So number 3. Rule number 3, we are saying all sulfates are soluble except lead 2 sulfate, which is written PbSO4, and barium sulfate, it's written BaSO4. Then we are saying not here. Calcium sulfate, which is written CaSO4, is slightly soluble in water. So you have to know that. We are saying all sulfates are soluble except 3. That one is lead 2 sulfate, barium sulfate, and also calcium sulfate, which we said is slightly soluble in water. That means it's not completely soluble in water. Then we go rule number 4. We are saying here all carbonates are insoluble. So the first 3 we are saying are soluble, but this one we are saying all carbonates are insoluble. Kindly note that. So we are saying except sodium carbonate, which is written Na2CO3, potassium carbonate K2CO3, and ammonium carbonate, which its formula is NH4 in bracket 2 CO3. So number 5, we are saying all bases are insoluble except again the bases of sodium, potassium and ammonium. The number 6, we are saying all sodium, potassium and ammonium salts are soluble. Like for example, if we're having something with sodium, if we're having sodium oxide or sodium hydroxide, those are bases of sodium, or we're having sodium nitrate, sodium chloride, sodium sulfate, sodium carbonate, all sodium salts and bases are soluble. That's what we are saying. All potassium salts and bases are also soluble, and all ammonium salts and bases are also soluble. Then lastly, we are saying note. Group 2 bases are slightly soluble in water. What are group 2 bases? We are talking about the bases of magnesium and also calcium. They are slightly soluble in water, but they are not completely soluble in water. Lastly, let us go to the extended questions. We have 2 extended questions. Number 1, we are to distinguish between normal salt and acidic salt while giving 2 examples in each case. And number 2, we are to name any 2 examples of salts and give chemical equations on how they are formed. Learners, that's the end of our class today. Thank you for watching.